So, welcome to episode 3 now of Absolutely Zero Knowledge. And this episode, I'm joined by Orest from Scroll. How are you, Orest? Okay?
Yeah, absolutely. Thanks for having me, Ed.
That's all right. No problems at all. So, yeah, I guess over the last couple of episodes, I've done the intros and bits and pieces. So, we'll get cracking straight into it. So, yeah, before we get started, do you want to give a bit of an overview, first of all, about yourself? So, who are you?
Absolutely. I guess I might be less of the typical persona that you encounter in this little ZK slash even crypto niche of ours, because I have not always been doing crypto since I was born. Instead, I actually did study and computer science, that it was, but also something non-technical. I did psychology and management as well. And with this background, I went on to found a startup in the mobile health industry right out of uni, basically. So it was quite a big endeavor for someone with only side project slash little hobby on during holidays kind of experience to go ahead and found a high-tech company. That was a crazy ride of ours that we embarked upon with the idea of using technology to help people with digestive disease.
Okay.
And so we created an app with which patients can track what they eat and maybe how stressed they are, etc. And it tries to then make correlations with respect to the symptoms, to the digestive symptoms that they develop, and applies some basic AI to highlight what sorts of correlations that the patient might want to look at more closely.
Mhm.
And so, with this in mind, we thought, hey, this is such a clearly technologist's dream problem to solve, because it's like those old school doctors everywhere that ask patients to take paper diaries and put notes, and then once per month come with the big book and
Yeah.
hope to actually be able to identify anything meaningful within the 20 minutes slot that was allotted. Like, of course, we would rejoice at the potential. Hey, like, this is clearly a technology problem. It will add so much value just, having a digital diary. But then reality came, and we found out a couple, like 50 employees later, and 3 rounds of investments later, that in the end, this is not as much of a technology problem as it is a human and empathy and compliance problem. So, in part because of that, my technical co-founder and I, we decided to hand over this company called Karake to our medical co-founders and phase out. And this actually took us like almost a year. It's quite scary when you come to think about it, how involved you get as a founder with the company that you create. Um, and then I basically took a little bit of a sabbatical and went to the mountains with a childhood friend of mine, only to find that COVID is actually um, coming to Europe, and that it's not just this like 3 day to 1 week long thing, but rather something that put us in a strict quarantine, and actually made us come to a new startup idea. Hey, let's fix events online. Everyone's in a quarantine or at least staying home, and those 100-person large Zoom calls, they are so different from a 100-person big in real life meeting, where you are able to actually make meaningful conversations, have those conversations, make real connections in small groups, in small subgroups that you establish organically, because you approach someone and then maybe you step to the side and you have the body language and all that. But also we are able to mingle freely between those small groups during a real event, which was not possible on Zoom. This was,
Yeah.
I think, right when Zoom started supporting those breakout rooms that no one even knew about, and even to this day they don't really solve this problem really. And so yeah, we ended up founding Knit, a second startup of mine, and did that for quite a bit. But we actually lost faith in the idea. It's not just that Zoom is incapable, it's actually a very hard problem to solve with technology again. And we decided to stop that. And for the 10th time, then my former Karaka co-founder, the tech co-founder, hit me up and bother me about those zero knowledge proofs
Hmm.
and multi-party computation. And I figured to myself, yeah, Dankrat, you are a theoretical physicist. Of course, you find those theoretical results interesting, but it's gonna take another 20 years until this is even a plausible thing to put to practice and to make a business out of. But this time I actually listened and I followed Dankrat's advice and read up and caught up on the developments in the space, and realized that this is no longer like this theoretical, academic, purely hypothetical thing, but something that really is becoming the reality now, the new reality. And so I started looking at actually no longer just treating blockchains and those theoretical constructs as a side hobby and a cool thing, a cool corollary to free and open source software, but actually thinking about joining full time myself. And I ended up doing that. I joined Scroll, a zero knowledge based rollup, which is a solution for scaling Ethereum. And I joined Scroll as a quite early employee and former co-founder, which de facto meant that we would be um, using like this resource to extinguish fires wherever they burned the hottest. And so I did that for a while, and then start focusing a bit more on what we call infrastructure engineering, which is the engineering bit that has to do with everything other than the zk circuits themselves. And in parallel, I also started. I was missing this in real life dimension that kind of became a scarce good since COVID, and that Knit didn't really help me solve. So I was missing the in real life conversations and interactions and so on. In the world of crypto, where pretty much everyone is working remotely, and so I decided to start a little, at first, study group, and then this became a meetup series on zk in Warsaw, where I'm now based. And so this became known as zk Warsaw, and grew to actually something that is no longer this intimate and private, small group where we study papers, but it actually culminated in a big conference, full day conference, a few months ago. The zk Warsaw Day, 2023. And it's super cool to see that these things actually see traction and that people are interested in learning about zk together, and that it actually seems to provide real value, that you be able to stand one next to the other, next to a blackboard, and talk some formulae through, rather than relying on digital materials alone.
Awesome. And thanks for that journey. And well, I mean, one question that I'll kick off with right away, and conversations that I've had numerous times already on this podcast and other conversations online and in person too. But I think people have the preconception that, this zero knowledge space is um, so difficult to get into. You need to have, maths and computer science background with a PhD from the best college in the world, to be even be able to get your foot in the door. Whereas, what's striking about your route is that, you come from a non-technical degree, you worked in a bit in the healthcare sector, a bit doing virtual meetings, and obviously you've done that as a CTO and co-founder, but ultimately you don't really have the typical profile of someone who might work in a technical role at a zero knowledge startup. And for those people who are in the space will know that Scroll are, one of the biggest players in the zero knowledge industry, if you want to call it that. So how does someone like you, and what advice would you give? How did you manage it? How did you get into that space? And what advice would you give for maybe people like yourself?
Yeah, absolutely. So just to manage expectations, I am a technical person, and I've been coding as a small kid, and I've been playing with Bitcoin since it was conceived. So it's not like this is something accessible to anyone, unfortunately. But what is also not true is that it's not true that you would need to have been doing ZK for the last 20 years in order to be able to contribute. That's not true at all. And actually, with my computer science background, I did find it challenging to catch up on the maths component, on like the for like I would say pretty theoretical and otherwise rarely relevant in computer science and engineering requirements that are imposed on your math skills. And because of that, it was that I actually decided, hey, let's run those reading groups. I have those literally 3 friends that I know are based in my city that are into maths. Let's go and read this polynomial commitment schemes paper together and try to teach one another. And it felt really like going back to school. Like I literally didn't use, like I didn't really deal with mathematical primitives of these sorts since I left school. And this had only been like tasting it very like lightly. And it helped me a lot. And it really helped to also orientate myself in the whole space and to understand what different types of categories we deal with and what those keywords and buzzwords that people tend to throw around and use for marketing and airdropping purposes, how they actually belong together and what they mean precisely. And so I can only recommend finding a group if you are this kind of person, maybe an IRL one, and using this peer support to your advantage and to motivate yourself and to also convince yourself firsthand that it's not just you who doesn't understand how the 7th phase of the 40th step of this little algorithm that seems like an obvious thing that every reader of the paper will be able to understand works. It's normal. These are highly specialized fields, and it was a huge surprise to me to find out that it is normal of a industry professional who has been doing, say, blockchain development for 10 years, like literally people who were there when the space was starting, that they don't know the intricacies of this new algorithm or this new data structure, even this new consensus research paper. This is normal. It's not you. It's not an imposter syndrome. This is normal. These are things that require time, effort, and it's up to you to decide how much you want to devote to that.
And I guess another question that I'd be keen to know: how did you convince Scroll in the interview process, of your capabilities? Because once again, you might be able to do some open source work, you might be able to read a few papers, you may be able to increase your knowledge in your own personal projects, but how do you actually showcase to a zk startup that you are capable in this space?
Oh, I was always very upfront about not being a zk engineer or a maths PhD. And I think it's important and valuable to to first of all be transparent and honest, but second of all, and that's kind of a prerequisite, to know where your resources, where your strengths and limitations lie. And in the context of zero knowledge startups nowadays, I think another misconception that people have is that zero knowledge startups only employ and only require zero knowledge engineers. This is not true, because there's a lot of orchestration, a lot of additional highly technical components, a lot of gluing those components and modules together that are just as important. And I would even argue it feels like in crypto, because crypto is so enthusiastic about the new and hot and sexy topics, that it kind of attracts people who are into that. It feels like in crypto in particular, we miss people who have seen a research paper become implemented and shipped and sold, monetized, the whole journey, and the learnings that such people could bring and apply to crypto to avoid those kind of first time business founders mistakes, because many of the things that a zk startup will run into are not specific to zk startups. They are just normal startup issues. And it's no, like, to give you an example, it's very common and not specific to crypto or zk at all, that your team, your engineering team, as it grows from this maybe one or two technical founders to three more ICs to maybe a middle manager, ranging to maybe 20 or 30 or 40 people. Each of these phases will come with its own challenges. And one example is, no matter if you're a zk startup in crypto or whether you are a bank, you will want to have processes for your version control. You will want to apply best practices, assuming you want to ship production code. You will want to, and not just an MVP in a prototyping stage, maybe as part of a more research or academic focused endeavor. If it's about production, great. You will want to apply best practices that are common across engineering. You will want to have isolation. You will want to have separation of concerns. You will want to have reusability. All of these things. You will want to have people assuring quality. You will want to have planning and a roadmap and milestones. You will want to have all sorts of non-technical elements as well. So these are all things that basically make up a big proportion of the day-to-day operations of a zk startup, just as
Yeah.
much as they do for a non-zk one. And so all of these people and specialties and skill sets and assets that people bring with them are just as valuable in a zk startup. It's just that, unfortunately, in some areas it feels like people don't value non-engineers or
Yeah.
non-zk engineers as much as they do otherwise. So this could be a hurdle indeed.
Yeah. And yeah, like you say, it's, I guess, the cryptography engineering side of things is just like you say, a very small proportion. These companies still require, your distributed systems engineering, protocol engineering, research engineering. There's a whole different number of avenues that if you are keen to get into this environment that you can go down. It doesn't just have to be the hardcore mathematical circuit design side of things. So yeah, I mean, you're now at Scroll, who, like I've said, are one of the most significant names. And I'll let you share a little bit more about what they're doing. But first of all, obviously, a lot of what they're doing, and what I've discovered is that although zero knowledge is used around sort of privacy and security, actually, you know, a large proportion of the use cases are all about scaling Ethereum. Do you want to share a little bit about what that means? And first of all, I've got a question which I don't think I've ever asked, but why isn't Ethereum scalable anyway? So yeah, what does that mean?
Yes, so the broad context is blockchains are a type of database that is distributed. And there can be several properties to a distributed database that people would deem valuable or advantageous. In the context of blockchains, we often speak of three important properties. These are security, decentralization, and scalability. And the problem is, it seems that it's very hard to get all three of them at the same time, to achieve a system design that would not have to compromise one of these three at the expense, like to the goal of achieving the two others. And so that had been a predominant conclusion for the last maybe decade or so, maybe a bit less, until recently. But back then, that was like the state of the art assumption. Hey, we have to pick which of these three properties to sacrifice in order to gain the other two. And Ethereum's designers, they specifically chose, and consciously so, to sacrifice scalability in order to have security and decentralization. These were the values upheld by the designers and by the community, for sure. And so this was a conscious choice, and it was made in the assumption that there's several research streams ongoing as to how to weaken this sacrifice, how to make this scalability problem less of a problem. And it turns out that actually one of those assumptions, one of those research directions that the early designers of Ethereum were hoping for is actually materializing nowadays. And so Ethereum basically elected to be this secure and decentralized. By decentralized, when we say that, we mean not only that there's like several, let's say, computers participating in such a database, but we also mean that the system design is made such that it encourages decentralization, rather than, for instance, a system design where in order to participate, you need to have beefy hardware. Like that would be a non-example wherein people are having a hard time joining such a network. And there's economies of scale. If you buy one server for $50,000, it costs you $50,000. But if you get 100 of those, it maybe costs you less. And so, because so few people will be willing to spend $5 million on some servers for some crazy network, this will lead to this decentralization becoming weaker and weaker, right? So Ethereum elected a design that should optimize for security and long-term decentralization, in the hopes that the research would catch up and make the scalability problem less bad. And right now, it seems that the idea of rollups, or more broadly, layer 2 scaling solutions for Ethereum, was was a good was a good one,
Mhm.
and it's actually happening. We have several layer 2 solutions. We have several rollups, and many of them are very promising in terms of leveraging the security and decentralization property of Ethereum, like inheriting those valuable, desirable properties, whilst on their own adding this scalability bit extra, which comes at some trade-offs, of course, some costs, but for the average user, a rollup um, is expected to mean that they have almost the same security and decentralization as Ethereum, but way more scalable a system. That basically means that you, if you want to run your swap on Uniswap on, for instance, Scroll, you will pay a fraction of the price. So we are talking about orders of magnitude of savings. So maybe 10 times more, 100 times more, 1,000 times more, less.
Yeah.
Um, so
So
yeah, that's the context that we are talking about when we say, hey, scalability, Ethereum rollups.
mhm. And that's where Scroll obviously comes into play, that the solution that they're providing. Do you want to touch on briefly what Scroll are doing? I know you touched on a little bit there, but what solution have they come to allow for the scalability of Ethereum?
Yes, so Scroll's idea has to do with the trade-offs, with the costs that come with a scalability solution like a rollup. There's several dimensions that you can consider. If we abstract away the less important ones, we can think about a two-axis, two-dimensional chart, where on the one axis we have the system performance or scalability, and on the other axis we would have the compatibility with Ethereum. Ethereum as the existing ecosystem of apps, of smart contracts, of users who compose those with one another and build bigger and bigger castles with those Lego pieces. And so the trade-off here seems to be the more performance you want, the more of the Ethereum compatibility you will need to give up. So you can either be very compatible with Ethereum and gain from this big network and the network effects of Ethereum and developer tooling being very mature and people knowing how to develop, people knowing how to use those tools, people like having wallets installed and stuff like that. Or you can elect to go fully on the performance axis and say, hey, we don't want this ballast, this burden of compatibility because instead we prefer to have even lower fees,
Yeah.
right? And now you can also elect to be somewhere on the trade-off spectrum here. And so what Scroll does is Scroll has this thesis that a certain level of compatibility is actually important enough as to not only justify a lower performance nominally, but also to actually lead to, through economies of scale, the performance not being less, but being similar to less compatible systems.
Yeah.
And so in the case of Scroll, we specifically target a bytecode level compatibility, which means that a developer who takes the Viper or Solidity code, compiles it towards the EVM, that they can take this bytecode that would be run in this Ethereum virtual machine environment and put it into Scroll's virtual machine.
Mhm.
And so this is like almost the highest bar you can get in terms of compatibility, and almost the lowest in quotation marks in terms of performance, because it's very difficult in terms of both designing such a system, making sure it's bug-free, You can never be sure, but trying to ensure it's bug free, trying to ensure it does what you hope it's doing. But also it's very difficult in terms of direct computational costs.
Yeah.
So coming up with a zero knowledge proof to verify such a transition is actually very costly computationally.
And you've mentioned these sort of keywords a couple of times, and in my head, I'd love to, for once and for all, really understand the differences or between a zkEVM and zkRollup. So but to me, they seem quite similar. But they're not interchangeable terms. I don't think. What do each of those things mean, and how do they differ, and what are their use cases or purposes?
Yeah. So a zkRollup is a layer 2 solution that posts some data about what is going on in this like separate network into Ethereum, and also convinces other Ethereum network participants that this new data about the new state that's going on in the new block in this separate network is correct by also posting a zero knowledge proof of the transition, of the state transition into Ethereum. That is what a zk rollup is. Now, a zkEVM is less well defined, but people usually mean some sort of a zk rollup that has some level of compatibility with the EVM, so with the Ethereum virtual machine. Now, why is that a special case? Well, you could have a zk rollup that has got nothing to do with Ethereum and nothing to do with the Ethereum virtual machine. You can maybe run your JavaScript in the zk rollup, and it posts, and there's some rules to the system, and it posts some like this resulting new state, like new view of the world into Ethereum and a zk proof to accompany it. And that's a perfect zk rollup, but it has got nothing to do with the EVM. And so a zkEVM could also be run without a rollup, theoretically, if we want to be strict. It's a zkEVM would be a virtual machine that is, to some extent, to be defined, compatible with the Ethereum virtual machine, and comes with a proof, zero knowledge proof, of the execution correctness. And it's just supernatural and a great synergy to put this into a zk rollup context and put this proof on chain that just makes sense for scalability and security and cost considerations.
Got you. And obviously there are a number of startups and companies working on from my perspective pretty similar technologies. The likes of Scroll are obviously like I've said, a massive name in in the rollups and zkEVM space. But there's also the likes of Polygon, MetaLabs or zk Sync. There's Tyco, Consensus, all seemingly working on very similar solutions. So why would an end user, or why would someone opt for one as opposed to another? Is it personal preference? Are there intricate differences that might be more suitable for one use case than another? How do they vary?
So for sure, there is this vibe component. Oh, I like this vibe. Or these guys seem like I align with the values or with the politics or convictions well. But the other thing is the technology. And here again, unfortunately, it's as said, like as much as I would wish for zk to be more accessible, unfortunately, you do need to have a pretty solid understanding of what's going on beneath the hood to understand where the trade-offs are being made. And this is also a big task and responsibility for us, the roll-up teams, to communicate these clearly. I think that we've seen some bad developments with respect to that recently. And so when it comes to the differentiation between Scroll and say MetaLabs product zk Sync, the difference is the MetaLabs rollup zk Sync is compatible on the language, on the programming language level with the EVM. And so what you can't do is take the bytecode that you compile towards the EVM and run it on zkSync. Instead, you need to take your Solidity, compile it towards the zkSync VM, and put that on the rollup. Why does this matter? Like, you just compile with the press of a button anyway, who cares? Well, maybe. Right now, though, it matters a lot, because having a separate bytecode actually means that a lot of tooling breaks. So for the developer out there, this will mean, hey, I can no longer use my debugger, because when I run my code and it corresponds to the different bytecode, I can no longer understand, my debugger can no longer understand where something happened during execution. So a lot of tooling needs to be adjusted to actually accommodate for such a theoretically subtle difference.
Yeah.
With respect to Tycho, for instance, the differentiation is Tycho has an even higher bar in terms of compatibility with the EVM. They actually want to be compatible with Ethereum. They want to be able to prove Ethereum blocks directly. That's even harder in terms of both the indirect, like the system design and maths and so on, and behind it, but also in terms of computational cost, and comes probably at a significant performance penalty. And then there's even more subtle differences, such as Polygon zkEVM. Polygon zkEVM and Scroll differ in a way that's almost invisible to the end developer. They differ in how they represent the intermediate, like kind of VM level stage. And what does matter for the developer, though, is how many training wheels or how many like temporary limitations a rollup imposes on you. So for instance, which precompiles are enabled, which precompiles are allowed, but also what are the limits, like what are the gas limits, what sorts of sizes and constraints do I need to keep in mind, that unfortunately nowadays are still different from the Ethereum world. So there's a lot of kind of nuanced and subtle considerations to be made. And in the end, this is a very active field of research, and also field of educating developers, educating users. And I think our mission will be in trying to make it more clear where the trade-offs are and what the best tool for a job is.
Amazing. Well, that's been very, very helpful for me to get a bit more of an understanding of zkEVMs, rollups, the differences, all the intricacies. So I really appreciate your time. We've got a couple of minutes, I know, before you've got to leave. I don't want to take too much of your time, but do you want to give a quick 1 minute shout out, or tell us a little bit more about what you're doing with zk Warsaw?
Yeah, so zk Warsaw has turned into, it was a project that I basically started to have some people to read papers together and deep dive into zk myself, because as an infrastructure engineer, I barely had the space to actually do the zk stuff itself. And it grew into a regular meetup series. We meet in Warsaw once per month and invite speakers from different areas to teach us either zk related or adjacent topics. And we also even ended up throwing a full day conference 2 or 3 months ago, the zk Warsaw Day, that we intend to repeat and build up this local community of people who are into zk and who are enthusiastic about sharing and learning together, and motivating each other to be doing so on an ongoing basis. So yeah, stay tuned for the next a couple of announcements. I think we will be announcing Ariel Gabizon, one of the Planck paper authors, coming to us soon, and we also intend to be running a second zk Warsaw Day next year.
And once again, I think it just re-emphasizes the zk community as well is one that, you know, everyone's willing to help, but there's so many different resources, whether in person or not, where you can learn more and speak with like-minded people who want to upskill in the area. So yeah, I'm sure the Warsaw community are appreciative of that. And yeah, I need to pick your brains about how we can do something similar in London. But yeah, that's all I wanted to cover. I massively appreciate your time. It's been a massive help for me, and I'm sure it will be for the rest of the zk community. And if you are in Warsaw, by all means, pop Orest a message or head along, and I'm sure we'll be able to welcome you to his zk Warsaw community as well.
Yeah, hit me up on Twitter. It's Orest TA, or zk Warsaw is the handle as well.
Awesome, and I'll share that too. So yeah, thanks so much for your time, Orest. It's been great to chat, and yeah, we'll speak soon.
Yeah, Ed, thank you so much. Have a great day.
Cheers. Bye.